Good morning everyone. Today we are starting up with a special lecture by Dr. Vasudeva on the topic protein engineering from farming to pharmaceuticals. Followed by we'll be having a special lecture from Miss Lucie Lukacovicova on the topic the supernatural of Spain. Then we'll be having a special lecture from Miss Sadhna Shankar IRS on the topic my journey of writing science fiction.
I am Aditya Raj, a Ph.D. research scholar in the Department of English at Patna University, Bihar, India, declare today's conference open. Thank you.
Welcome to this session on protein engineering. Today we are going to discuss protein engineering from farmland to pharmaceuticals. So this is Dr. Vasudeva. Currently I'm working as Associate Director in Pure Software Private Limited. Earlier I was working as pharma scientist in Novozymes South Asia Private Limited. You will understand in the next couple of slides on the topic protein engineering, and the agenda would be to go through protein engineering. Initially, we'll start with the structure of proteins, function and importance of proteins. Then we'll move to a class of proteins called enzymes for industrial application. And we will see what exactly is protein engineering, and then why do we need to engineer protein. Then we will move to protein engineering concept, method. And in this presentation, I have taken up one example of engineering protease. That's the case study. Finally, we will move to summary and way forward. So as we all know, proteins are the large complex molecules, and these are critical for normal functioning of the cells. So seen here towards your right top corner are the sources of protein, and proteins form 20% of the human body. This itself speaks for the importance of this protein. And proteins are quite crucial for the structure, function, and regulation of the body tissues and organs. We'll further take a look at the protein structure. It's a kind of insight. So as you can see here, proteins are the macromolecules made up of individual units or the smaller units called amino acids. So these amino acids are joined together by peptide bonds, and the proteins exhibit or show 4 levels of structure: the primary structure, the secondary structure, the tertiary, and the quaternary. So this quaternary structure is quite important, and this represents the fully folded form of the protein. So it is this form which is quite important for the protein to be functional. And proteins are the most versatile molecules in the living system and serve crucial functions in essentially all biological processes. That you will see in the next slide here. Proteins, they act as enzymes, they act as hormones, they are involved in the transportation of respiratory gases. They are the structural components of cells, and they are involved in the defense, so on and so forth. That's why I have given the title here as proteins are indispensable. The food that we eat contains carbohydrates, proteins, and lipids, and these are digested by enzymes. Enzymes are involved in almost all metabolic activities of the cell, and hormones are one such example of proteins. They also control various activities of the body. And as I was just mentioning, in the transportation of respiratory gases, the hemoglobin present in RBCs play an important role. In addition to being transporters, enzymes, and hormones, the proteins are also involved in the structural maintenance of the cells, especially the proteins like actin and myosin. The proteins like actin tubulin and keratin are involved in the structural maintenance. If we talk about the immune system, the immunoglobulins are also proteins, kind of proteins. And for the contraction and relaxation of muscles, we need proteins like actin and myosin. So these are various functions that the protein perform, and enzymes are the most important class of proteins for the industrial purposes. So these are, of course, modified proteins. And if I give you a few examples and tell you that enzymes are widely used in industries, you will be surprised. Enzymes are used in detergents. For example, amylase, protease, lipase, and many other enzymes are used in detergents, both liquid as well as powder detergents. These are important because they remove the food-based stains. Not only detergent industry, the baking industry makes use of enzyme. At the bottom of each picture, I have given the kind of enzyme used in each industry. So dairy makes use of enzymes, pharmaceuticals make use of enzymes, and then we also have feed industry that makes use of enzymes. Biofuel, of course, glucoamylase is an example. Biofuel industry also uses enzymes. Textiles, leather industry, beverages, paper and pulp industry, and we have agriculture and waste management. All these different sectors, they use enzymes. And at the same time, I want to give you a bit of introduction to protein engineering, because if you look at the conditions that we have, so there are different environments. When I say environment, it means different temperature, different pH, different metal ions involved. All these are different climate, or all these are, to be precise, different environment for the enzymes. So we cannot expect the enzymes to be functional in all these environments. And all these are possible because of protein engineering. Otherwise, we wouldn't have seen the growth of these industries. Then the question comes, if we already have enzymes, does it work everywhere? Can we make it work in all these environment? The quick and simple answer is no, because enzymes need to have special properties to be able to perform in all these different conditions. As you can see, enzymes should be intact to perform its activity. As we discussed, the fully folded form of protein is functional, and if it loses its structure, then it will not be able to perform its normal functions. And as we also discussed, the industrial applications involve harsh environment like very high or very low pH. It might involve very high or low temperature. Sometimes the enzymes need to work in presence of very low amounts of water. Sometimes the denaturants like surfactants are also present, and the enzymatic process sometimes need to be performed for a very long time. And the climate or the environment, not the climate, the environment also involve other denaturants. So for the enzymes to be functional in all these cases, it needs to be changed, or at least the properties of the enzyme needs to be changed so that they adjust themselves to this environment, or they are stable in all these environment. And if you look at the actual process, or what exactly is protein engineering and why do we need to engineer the protein? So to define the protein engineering, it's simply designing new enzymes or proteins with new or desirable property. To put it in a layman's perspective, the process of developing useful or valuable proteins is called protein engineering. And I'll give you two examples here that will tell you why we need to engineer proteins. The two examples given here, human beings are in two different environments. And each of this environment, it demands its own tools. And so is the case with protein, because protein engineering is done for various purposes. Sometimes it is for increasing the stability. Sometimes we need to increase the activity of an enzyme, and we need to stabilize the enzyme against solvent, against metal ions. And these are few examples. There are various industrial requirements based on which the enzymes are engineered, and the native enzyme cannot function in all these different environments. It needs different tools. And now coming to the principle of protein engineering. So by modifying the amino acid sequence of proteins, we can also modify the structure and function. That is the basis for protein engineering. And it simply means that if I change an amino acid that you are seeing here, the property of the protein changes. And similarly, I have taken up one case study where we will see as to how we can increase the thermostability of the protease. So how to engineer a protein? The case study that we have here is of a protease. So what is this protease? So protease is an enzyme that breaks down the complex protein molecules into peptides and amino acids. So for the sake of understanding, let us assume that the protease that we are talking about performs at 38 degrees, and the industrial requirement is to increase the temperature tolerance of this protease to 50 degrees. So now the task looks challenging because it is now active, happy, and performing fine at 38 degrees, and you have to make it work at 50 degrees. So what happens at higher temperature? If we look at the structure of protein, the quaternary structure is quite important, and for the enzyme to be functional, it has to be in a proper folded condition. As soon as you increase the temperature, the protein tends to unfold and you will end up with a linear peptide like this. And what we need to do, because our protein or our enzyme, which is protease here in this example, is fine at 38 degrees, but unfolds at 50 degrees. Now, the aim of our project or this protein engineering project is to stabilize this protease against unfolding. If at all you are able to keep the protein folded at 50 degrees, then you will be able to see some functioning of this. So for that, we need to increase the stability of protease to the temperature. We will see how it is done. You can see here the crystal structure of a protease. And how do we engineer this? There are different methods or steps involved in protein engineering. So I have generalized all these methods, and I'll take you through one example of protein engineering with the help of protease. The first step to do is select protease from a donor. When I say donor, this is usually bacteria or fungus from which we identify the protease first. And if that protease needs to be stabilized to higher temperature, we need to do various protein engineering activities. The first step, as I said, is select the protease from the donor organism, and we call this as wild type enzyme. And clone and express the protease. This is the next step. And what we basically do is we will take out or isolate the gene that is responsible for the production of protease, and we'll fragment it and keep it separate. At the same time, you can see here, bacteria will be having circular DNA fragments, circular DNA called plasmids, and these plasmids are also isolated. And in the next step, what we do is we will fuse the gene fragment, that is the gene producing protease, with the plasmid that we have. Now, the plasmid of the bacteria will have the protease gene, and we will put this plasmid back into the bacteria. Now, in addition to what the plasmid produces, the bacterial cell also starts synthesizing the protease, because we have already added the gene that is responsible for the protease production. So just to quickly summarize, from a donor organism, we selected a gene, and then we have put that gene into plasmid, and we have put that plasmid to a bacteria, which is now producing the protease of our interest. And first thing that we need to do is we should check the activity of this protease, and then how stable is this to temperature. And I have given here one graph where we see that the temperature has a detrimental effect on the activity of this protease. And the maximum activity you can see at 38 degrees. And there is no activity at 60 degrees. And what we basically need to do is the protease that we have selected needs to be stable at 50 degrees and not 38 degrees. And that is where we have to decide what to be done. So to increase the stability of protease to temperature, we first need to identify the regions which are unstable. The regions of this protease could be unstable, and there are various methods by which we identify the unstable regions of the protein. So it could be by crystal structure or NMR, or by computation method, or using the experimental data that we already have. The first task in protein engineering is identifying the fragile or unstable regions of the protein. Once we identify this, we will see as to how the enzyme is behaving. Just to recall or reiterate, this enzyme is active at 38 degrees. And as the temperature increases, the enzyme loses, or the protease loses its activity. And for the sake of understanding, let us assume that at 50 degrees, there is almost 10% activity left. So from 100%, it drops down to 10% at 50 degrees. Now, we have to identify the regions of the protein that are unstable. So by various methods that I mentioned before, we have identified the fragile regions or spots in the protein. So these are called the hotspots. And for the sake of understanding, I have given you the example of 8 regions or 8 positions which seem to be fragile. So these are starting from 1, number 2 here at different regions of the protein, number 3, so on and so forth. It's not just enough to identify the fragile regions of the protein. We also need to change or replace the amino acid at each of this position and check again what happens to this temperature tolerance. If my wild type enzyme is active at 38, can any of these proteins that I have mutated or the enzyme that I have mutated gives additional benefits? So what we do here is we will mutate this protein, we will replace the amino acid, and we will check the activity at different temperatures. And shown here is an example where out of 8 mutations that we tested, mutations at position 2 and mutation at position 7, where we have replaced alanine to glycine at position 2 and where we have replaced serine to threonine at position 7. So these 2 positions are giving additional stability. And the same you can see here graphically represented. The wild type had just about 10% activity at 50 degrees. And the mutation 2 or number 2 is showing 25% activity at 50 degrees centigrade. And the mutation 7 is showing around 40% activity at 50 degrees. So this simply means the wild type enzyme, which had 10% residual activity, has 2 hotspots at the position 2 and position 7. Now we have replaced that with other amino acid, and replaced amino acids are giving additional stability, and that's why you are seeing an increase in the activity from 10% to 25% and then to 40%. So that means we have increased the thermotolerance of this protein. It is still active at 38 degrees, but the stability of the protein is increasing at 50 degrees, and hence you're seeing an increase in the activity. So the protein engineering is an iterative process. This does not stop here. After you identify these two mutations, which are giving additional stability to this enzyme, what we do basically is we will combine these two stability inducing mutations. So the original protein did not have any mutation. We introduced many mutations and checked the activity, and we found two mutations to be beneficial. And those two mutations are combined again on the wild type protein, and you will see an increase or further increase in the stability. So this is just an ideal condition or situation, but not all the times we will be lucky to have such mutations. There are cases where this protein engineering program takes years together. There are cases where it can be done within few months. It depends on your ability to identify the fragile regions and your ability to fix it. Here, we were lucky enough to see two stability-inducing mutations, and when we combined, again, we could see an increase in the activity. Now, from 10% activity of the wild type, after combining the mutation 2 and mutation 7, we have reached a stage where the residual activity has reached to 60%. So this is how we can engineer an enzyme to towards thermostability. Similarly, there are different concepts used for different protein engineering programs. If you want to increase the activity, different concepts are involved. If you want to increase the pH tolerance, the concepts that we use will be different. So depending on the industrial requirement, we change our protein engineering concept, and more or less the overall process remains the same, where this is an iterative process where we start combining different beneficial mutations. So this brings us to almost the end of our presentation or topic of discussion. Just to quickly summarize, enzyme reactions are alternative for polluting and harsh chemicals. It's easy to control and no harmful byproducts are involved. And lesser use of hazardous and harsh chemicals are one of the key features of enzymatic processes or reactions. And I would definitely say it's the future answer to sustainable growth. And the beauty of protein engineering or enzyme engineering is that any enzyme can be engineered for industrial application. Of course, it depends on the requirement. And finally, the enzymes for burning issues of the world. If you look at this, we are having various environmental, or other associated problems like plastic degradation, municipal waste management, wastewater treatment, pharmaceuticals also makes use of enzyme. So these three, the top three are the big, environment problems that we are facing today. Enzyme engineering can be a good answer for this. So in addition to this, pharmaceuticals are also using enzymes, and engineering enzymes can be beneficial to even pharmaceuticals as well. Of late, lots and lots of companies are coming into this sector, and they are using enzymes for pharmaceuticals as well. Slowly, people are also realizing the benefits of using enzyme and also the potential of using enzymes for various diagnostic purposes. So with this, I would like to quickly conclude that enzymes are the future, and this is the future answer to the sustainable growth. So protein engineering is one example where we can have answer, or where we can answer all the questions that we have in front of us today. Thank you.
My name is Lucie Lukacovicova. I'm from Prague, from Czech Republic. I'm a science fiction and fantasy author. I have 6 novels published and over 100 short stories. In English, if you would be interested, I have a short story in the anthology Recognize Fascism, also in the Grantsville Gazette 101, and in autumn my short story will be published in a prestigious anthology, Life Beyond Us. Welcome to my lecture about supernaturals of Spain. My lecture is focused on the supernatural of Andalusia, especially cities of Malaga and Marbella. The folklore of Malaga speaks about quite a lot of different ghosts and apparitions. The most famous haunted location is Cortijo Jurado, which is a house on the outskirts of the city, completely abandoned. The legend has it that it belonged to a rich family in the 19th century, and that many dark rituals took place there of dark magic and demonic invocation, and that there were young girls and children sacrificed in the rituals, and that their ghosts still wander the location. It is a very favorite place for ghost hunters and urbex fans to go. The place is still very mysterious, and there were reported sounds, lights, strange feelings in the place. This type of haunted house is basically quite a modern tradition, modern style of story. Much older legend is attached to Cementerio de San Miguel, the San Michael Cemetery, which is the haunting of animas negras, souls which are in the purgatory, and they are able to communicate with the world of the living, and they are able to fulfill the wishes of those who are able to contact them, and it is possible to exchange favors between the living and the dead, which is basically a very interesting pattern akin to demonic invocation, or to necromancy. It could be considered on the borders of black magic, but it depends largely what the living person wants the animas negras to do, what is the idea, the motivation, and the wish which makes the action either beneficial or evil. In St. Michael's Cemetery, there it is also said to appear ghost of the American writer Jane Bowles. And her fans, her readers, till this day sometimes gather at her tomb on the anniversary of her death. And some of them reported that among the people present they saw an unknown woman, and that later they recognized her as Jane Bowles herself, who simply attended the gathering held in her own honor. The ghost of Jane is harmless. There are no reports that it would somehow hurt anybody. It's just mysterious and unnerving, sometimes walking through the cemetery at night. Jane Bowles was born 1917 in New York and died in 1973. She was very eccentric. She wrote a play in the summer house and a novel, Two Serious Ladies, which is very strangely unsettling and charming. And in the end resided in Malaga and died there, and is buried in St. Michael's Cemetery. So she is one of the more modern apparitions of Malaga. Another interesting haunted location in Malaga is El Cementerio Inglés, English cemetery, which was founded in the beginning of 19th century, because the inhabitants of Malaga were predominantly Christian Catholic. There was a problem to bury, for example, Anglican Protestant Christians who had no cemetery of their own. So the English consul, William Mark, managed to gain a plot of land where an English cemetery, a Protestant cemetery, could be built. The story says that always the last person buried on the place, his ghost or her ghost, would become the guardian of the place, of the said cemetery. In this case, it was a certain Antonio Alcaide who before, during his life, was a physical guardian of the cemetery. So he was the last one to be buried there before the burial on the locations stopped. Another famous Malagan ghost is the Hombre sin rostro, a faceless man who haunts the Casa Cervantes. There is a small well in the courtyard of the house, and it is said that by accident a man fell down into the well face first, and although the well was shallow, it was so narrow he was not able to turn around, and he drowned before anybody could help him. And that when they pulled him up, his face had such an expression of horror and fear and pain that when they buried him, they covered his face so it wouldn't frighten the living. And since then, the man appears in the house at night, basically without a face, without any facial features, which is, I would dare say, much more frightening than to have a face with an expression of horror. As we can see, Malaga really has got many different ghosts from different times. From other supernatural beings, we can find at least 2 snakes, basically representing the earth or powers of the devil. One of them is the devilish snake from the cave of Belda. Above the cave of Belda, during the times of the Reconquista, there was a Muslim fortress called Medina Belda, and it was resisting the Christian attacks and the siege for a long time. Also, the captain of the Christian army died during the siege, and the army was further led by his son, who was not so experienced, and it seemed that there is no chance to gain the fortress and that the siege will have to be lifted. It was told during that time that the Muslims are aided by the devil himself, and that the devil, the demon, resides in the cave beneath the fortress. So a priest who was accompanying the Christian troops went at night to the cave and he prayed there, and as he was praying, suddenly there was great thunder and loud noises, and from the cave were suddenly running lots of frogs and bats and other animals. And finally he saw a huge snake which tried also to escape from the cave, but the priest bound it there, made the demonic snake to stay there presumably forever. As the devil was rendered harmless, the siege continued and the Christians successfully conquered the Medina Belda. In the area there is still a local custom to hold a festival, a part of which is the tradition of binding the devil, atar el diablo, which is supposed to ensure that the snake, that the demon, will stay in the cave forever. Also, it is connected to local treasures and hidden riches in the cave. So basically that's the symbolic touch of the demonic, the underground, the riches, precious metals, and death, and the other side, and the underworld. These symbols quite often mix and collide in some way. Another huge snake of Malaga is said to appear to this day under the building of a hospital. It was Hospital de 18 de Julio, which was haunted by the presence of the snake, which simply appeared in the lower rooms. There are no reports that it would attack or devour somebody, but understandably the people were afraid and the hospital was closed. Then for some time there was a hotel on the location, but it suffered the same fate. It was closed, and now there are some offices in the place, and the lower rooms are not accessible anymore. But the legend has it that the huge giant snake is still there, and it still feeds on the rats and on the rests which it can find, and if the doors would be opened, it would come to haunt the building once more. Now let us have a look at another city, at Marbella. Also quite a lot of ghosts. Particularly quite well known and scary one is Mariquita la Alta, Old Mariquita, Old Mary. The legend of Mariquita la Alta says that there was a small girl who was sent by her mother to buy offal, insides of some animal or bird for the family to have for dinner. But the girl somehow lost the money and could not accomplish the task, so she was sitting at a stair in front of some house and was crying. A woman went by and asked what was the matter, and the girl told her she lost the money, and the woman said, well, old Mariquita died in this house, go and get her insides. The girl did so, and she took human insides. She took the innards of the woman, of Mariquita, and the family ate it for dinner. And since then, Mariquita la Alta was able to appear as a ghost to naughty children, appearing at their bedside, at the feet of their bed. And it was a ghost used to frighten children so they would behave, so they would go to bed and be quiet and possibly sleep. But, well, not sure about the sleeping, as they were so much frightened of the Mariquita. Another famous Marbellan ghost comes from the times of the Reconquista, when many Muslims were forced to flee the area, to abandon their houses, to move elsewhere. And of course they had some riches, they had money, they had gold, and it was impossible for them to carry it all with them. So there is said to be quite a lot of hidden treasures which stayed there. Their owners were never able to recollect them again. One of these treasures is said to be hidden in the city wall of Marbella and is guarded by El Moro Mustafa, the Muslim Mustafa. Parts of the treasure can be gained by somebody who is valiant, is brave enough to come there successfully in 3 nights and to face the ghost of Mustafa, who transforms himself first into a large dragon covered in fur, or snake covered with fur, then into a huge toro, huge bull with fiery eyes and breathing fire, and then into a Muslim warrior who seems to attack the person who came for the treasure. If somebody is able to stay there, not to run away, then he has the right to get some part of the riches which Mustafa is guarding. In Marbella, there are also martinillos, which are not ghosts, but very ugly gnomes, small dwarfs, small beings, which sometimes guard treasures, or sometimes they simply do some mischief. In one of the streets of Marbella, Calle del Viento, it is said that they were throwing stones out of nowhere, simply on anybody who was passing through the street, and the martinillos didn't like him. As we can see, in Malaga and Marbella, the vast majority of supernatural beings are ghosts, and the rest are snakes or gnomes, which are beings connected to the earth or the forces of the beyond, or possibly some connections with the devil. This is most probably due to the majority of the inhabitants being Christian Catholic, and their world view more supported the idea of ghosts and occasionally some devilish apparition. In this area, the folklore does rarely include any natural spirits. We nearly can't find any burning horses or mermen or these type of elemental natural beings. But what is important is that the choice of ghosts from different eras and of different character, which some of them are completely harmless, some of them are dangerous to the living. The possibilities are very wide, and the folklore is very interesting. My lecture is by no means all-encompassing, is not absolutely complete. If you have any questions, any ideas, or you have encountered some other interesting supernatural happenings in Malaga, Marbella, or surroundings, do not hesitate to let me know. And thank you for listening. Bye.